Let's go back to our meal. The average American takes in over 40% in fats. While there is no set amount of fats to take in, it is recommended that it should be less than 40% of your overall diet. We eat our fats in the form of triglycerides, shown here, in items like avocado, cheese, and oil used to cook. So what happens to these fats that we eat? That is lipid metabolism, all the chemical reactions that occur with our eaten triglycerides. When you eat triglycerides and also excess glucose from carbs, they are both stored as fat in adipose tissue. Recall from anatomy that adipose tissue looks like this slide is fat. The process of building up glucose and triglycerides into storage form in adipose tissue is called lipogenesis. Again, let's look at this term. Genesis means to make or create, and in this case, it is lipo, or lipids. So lipogenesis is the creation of lipids or fats. If the body has excess of adipose tissue, this can lead to metabolic syndrome, which is a combination of health issues, including but not limited to hypertension, high blood pressure, diabetes, cholesterol, which can then increase the risk of heart attack, stroke, and other conditions. Now, it's not bad to have some adipose tissue. It is important for insulation and cushioning, and as we learned previously, it is a good form of energy storage. While carbs are good, quick-to-use source of energy, they don't store as conveniently long-term. Fats store energy well, and they are actually the most concentrated source of energy. They have about twice as much energy than glucose or protein. For every 1 gram of fat, you get 9 calories of energy versus only 4 for carbs or protein. So we can take the fat or lipids in the form of triglycerides from the food we ate or adipose tissue fat stores and break it down for energy. Recall that triglyceride is 1 glycerol backbone and 3 fatty acid chains. In the process of lipolysis, the larger triglyceride is broken down into the glycerol and individual fatty acids. The fatty acids are what is storing the energy in all the bonds. Next, we'll see how we can use the fatty acids in lipolysis to further break down to release energy. Let's look at the meaning behind the term lipolysis. Remember, lysis is to break. So lipolysis is to break apart lipids. You might know the term liposuction, which is a procedure to reduce fat. Lipo is for lipid or fat, and suction is to suck out. So when do you need to do lipolysis? Let's say you haven't eaten in 4 hours, so you have depleted your blood glucose. Now you have to access your fat stores for energy. Or let's say you didn't eat enough carbs. Again, you would access fat stores for energy. This is the basis of the low-carb diet. It makes you use fat stores as your energy source until you break down and lose fat. Ultimately, we will use the triglycerides to make ATP and, when needed, ketone bodies. Let's start off with ATP, as this is the most common pathway for fat breakdown. The fatty acid goes through a process called beta oxidation, which converts the fatty acid to acetyl-CoA. Acetyl-CoA can then travel through the blood to the cell that needs the energy. You may recall that acetyl-CoA can be made from pyruvate acid from glycolysis, and then it can be converted into citric acid to enter the citric acid cycle, which is step 2 of cell respiration. Then you can proceed to step 3 of cell respiration, the electron transport chain, which can produce lots of ATP. That is how your standard cell can break down fat for energy to get ATP. But here's a problem. Acetyl-CoA cannot cross the blood-brain barrier. What that means is that your brain cannot directly utilize the energy from fat. It prefers to get its energy from glucose sugar in the blood real quick, which is where the term sugar high comes from. But what if you don't have enough glucose in the blood? Here's where ketone bodies come in. Recall it is a form of lipid. but it is only formed in emergency situations, such as in starvation mode. So let's say someone is in starvation mode and has an extremely low BMI, or perhaps is doing a long fast and not eating. They will have low blood sugar, so the brain will need an alternative source of energy. Acetyl-CoA can't cross the blood-brain barrier, but what happens is that it is converted through the process of ketogenesis into ketone bodies. So again, look at that term. Genesis is to create, and in this case, keto stands for ketone body. The reason why ketone bodies are created is that they can cross the blood-brain barrier and therefore can enter the brain. Once they get into the brain, ketone bodies revert back to acetyl-CoA and then can proceed in cells of the brain through cell respiration to provide ATP energy for the brain. So notice, a normal healthy person should not have ketone bodies. It is an indication that your body is in an emergency starvation mode. So if detected, it indicates a lack of homeostasis. We just discussed how we can store up excess glucose and triglycerides through lipogenesis to create triglycerides in adipose tissue. This is a good source of stored energy, which can be used later. When you need to use the stored energy in fat, you break down the triglycerides through lipolysis and then beta oxidation to get acetyl-CoA. This acetyl-CoA circulates in the blood cells to the cells of your body to enter the citric acid cycle of cell respiration to make ATP for your cells. An exception is if acetyl-CoA needs to go to the brain. It needs to be converted through ketogenesis into ketone bodies, which can then enter the brain. After in the brain, it can be converted back to acetyl-CoA and then go through cell respiration in the cells in the brain for ATP energy. Now you try to explain where carbs go with this diagram in your own words. To summarize, lipid metabolism one more time. Triglycerides and excess glucose can be stored as fat via lipogenesis. Lipids can be broken down via lipolysis and beta oxidation to acetyl-CoA, which can then be used for cellular respiration and ketone bodies for ATP.